morning, YouTube. It's Sunday, October 8th, 2017. If a tree falls in the forest and no one hears it, does it make a sound? Person 1 says it makes a sound just like any other falling tree. Person 2 says, but how can there be a sound that no one hears? The standard rationalist view would be that the first person is speaking as if sound means acoustic vibrations in the air, and the second person is speaking as if sound means an auditory experience in a brain. If you ask, are there acoustic vibrations or are there auditory experiences, the answer is at once obvious, and so the argument is really about the definition of the word sound. I think the standard analysis is essentially correct here. So let's accept that as a premise and ask, why do people get into an argument like this in the first place? What's the underlying psychology? Mistakes are often more revealing of cognition than correct answers. Getting into a heated dispute about whether if a tree falls in a deserted forest it makes a sound is traditionally considered a mistake. So what kind of mind design corresponds to that error? In Disguised Queries, I introduce you to the Bleg-Rube classification task in which Susan, the senior sorter, explains to you that your job is to sort objects coming off a conveyor belt, putting the blue eggs or Blegs into one bin and the red cubes or rubes into the other. This, it turns out, is because Blegs contain small nuggets of vanadium and rubes contain small shreds of palladium, both of which are useful industrially. For the sake of simplicity, let's forget the characteristics of flexibility or hardness and opaqueness or translucency. This leaves us with 5 dimensions in ThinkSpace: color, shape, texture, luminance, and interior. Around 2% of blue egg-shaped objects contain palladium instead of vanadium. So if you find a blue egg-shaped thing that contains palladium, should you call it a rube instead? You're going to put it in the rube bin, so why not call it a rube? But when you switch off the light, nearly all Blegs glow faintly in the dark, and blue egg-shaped objects that contain palladium are just as likely to glow in the dark as any other blue egg-shaped object. So if you find a blue egg-shaped object that contains palladium and you ask, is it a Bleg? The answer depends on what you have to do with the answer. If you ask, which bin does this object go in, then you choose as if the object is a rube. But if you ask, if I turn off the light, will it glow? You predict as if the object is a Bleg. In one case, the question, is it a Bleg, stands in for the disguised query, which bin does it go in? And in the other case, the question, is it a Bleg, stands in for the disguised query, will it glow in the dark? Now, suppose that you have an object that is blue and egg-shaped and contains palladium, and you've already observed that it is furred, flexible, opaque, and glows in the dark. That answers every query, observes every observable introduced. There's nothing left for a disguised query to stand for. So why then might someone feel an impulse to go on arguing whether the object is really a Bleg? Again, what kind of mind design corresponds with this error? Someone with a very naive understanding of artificial neural networks might design something like this. They've read excited popular science books about how neural networks are distributed, emergent, and parallel, just like the human brain, but they can't derive the differential equations for gradient descent in a non-recurrent multilayer network with sigmoid units, which is apparently a lot easier than it sounds. This network has a number of disadvantages, such as potentially oscillating or chaotic behavior, or having its connections square with the number of observed characteristics. But the network structure does have one major advantage. Every unit in the network corresponds to a testable query. If you observe every observable, clamping every value, there are no units in the network left over. But this isn't what the error feels like. If it did, the question, if a tree falls in the woods and no one hears it, does it make a sound, would make no sense to even ask. Given that you know that a tree falling generates acoustic vibrations and that no one is there to have the auditory experience, there's no question left to ask. You have all the data to have. That's not what the error feels like from the inside, though. From the outside, it might be something like this. This network is fast, cheap, scalable, and has an extra dangling unit in the center whose activation can still vary even after we've observed every single one of the surrounding nodes. which is to say that even after you know whether an object is red or blue, egg or cube, furred or smooth, bright or dark, and whether it contains vanadium or palladium, it still feels like there's a leftover unanswered question. Is it really a bleg? Usually, in our daily experience, acoustic vibrations and auditory experiences go together, but a tree falling in a deserted forest unbundles this common association. And even after you know that the tree falling creates an acoustic vibration but not an auditory experience, it still feels like there's a leftover question. Did it make a sound? We know where Pluto is, and we know where it's going. We know Pluto's shape and Pluto's mass. But is Pluto a planet? Now, remember, when you look at this network as I've laid it out here, you're seeing the algorithm from the outside. People don't think to themselves, should the central unit fire or not, any more than you think, should neuron number 12,234,487 in my visual cortex fire or not. It takes a deliberate effort to visualize your brain from the outside, and then you still don't actually see your brain. You imagine what you think is there, hopefully based on science, but regardless, you can't directly access the internal neural structures through introspection. That's why the ancient Greeks didn't invent computational neuroscience. When you look at the network, you are seeing from the outside. But the way the neural network feels from the inside, if you yourself are a brain running that algorithm, is that even after you know every characteristic of the object, you still find yourself wondering, but is it a bleg or not? This is a great gap to cross, and I've seen it stop people in their tracks. Because we don't instinctively see our intuitions as intuitions. We just see them as the world. When you look at a white mug, for example, you don't think of yourself as seeing a picture reconstituted in your visual cortex, although that is what you're seeing. You just see a white coffee mug and think, wow, look, this mug is white. Not the picture in my visual cortex of this mug is white. And in the same way, when people argue over whether the falling tree makes a sound or whether Pluto is a planet, they don't see themselves as arguing over whether a categorization should be active in their neural networks. It seems like either the tree makes a sound or it doesn't. We know where Pluto is and we know where it's going. We know Pluto's shape and Pluto's mass. But is it a planet? And yes, there were people who said this was a fight over definitions. But even that is a network 2 sort of perspective because you're arguing about how the central unit ought to be wired up. If you were a mind constructed along the lines of network 1, you wouldn't say it depends on how you define planet. You would just say, given that we know Pluto's orbit and shape and mass, there's no question left to ask. Or rather, that's how it would feel it would feel like there's no question left to ask if you were a mind constructed along the lines of network 1. Before you can question your intuitions, you have to realize that what your mind's eye is looking at is an intuition, some cognitive algorithm as seen from the inside, rather than a direct perception of the way things really are. People cling to their intuitions, I think, not so much because they believe their cognitive algorithms are perfectly reliable, but because they can't see their intuitions as the way their cognitive algorithms happen to look from the inside. They just see them as the way the world is. And so everything you try to say about how the native cognitive algorithm goes astray ends up being contrasted to their direct perception of the way things really are, and discarded as obviously wrong. This video comes from the essay How an Algorithm Feels from the Inside by Eliezer Yudkowsky. Scott Alexander describes this essay as the gift that keeps on giving, giving it so high of praise as to say that you can get a reputation as a daring and original thinker just by copy-pasting it at different arguments with a couple of appropriate words substituted for one another, Mad Libs-like, and describing it as the solution to something like 25% of extant philosophy problems. This concept and these charts are super important, and we will keep coming back to them. So if you're confused by anything here, links to the original essays are provided in the video description. As always, thank you so much for watching. Be sure to like, comment, and subscribe. If you're a fan of mine, you can support me on Patreon. Links to that, along with my Twitter, blog, and Discord server, will be in the video description. Take care, YouTube. This is Hive Apocrita. Until we meet again.